Welcome back to Topic 9, our factorable quadratics unit. Today we're actually going to take a step away from solving quadratics. We've actually done all we need to do for this unit, and we're going to turn to our second focus, which is goal 25. I can graph a factorable quadratic equation in two different forms, and I've written the forms up top here. You don't need to do too much with them right now, but we have these two forms. Today we're just going to focus on the first. In fact, the next couple days will just be on the first, and we'll finish topic 9 with the second. So that's why our daily learning target focuses on graphing in this form, which is called intercept form. Now, a couple things are going to happen here. First, we need to realize that we've graphed quadratics before. Topic 7 was all about graphing quadratics, but in Topic 7 our quadratics were in the form of y equals a times x minus h squared plus k. We called it HK form or vertex form, and we saw that little square. We even talked about how the square is a big giveaway that something is quadratic. Now here I am telling you that this equation is also quadratic, which seems a little bit weird because we don't quite see a square there. We'll have more on that later on. However, what we're going to do for today is graph by inspection. We're actually going to create 3 graphs first using some technology, and then we're going to use that technology to be able to check our work so that we can discover how to do this by hand. So without further ado, go ahead and open the Desmos app, or if you don't have the Desmos Graphing Calculator app, navigate to www.desmos.com. And once it loads, there'll be a big button that says Start Graphing right in the middle of the page. Click that button. Then you're going to graph the following 3 equations on your calculator. 1, 2, 3. Now I labeled my equations f of x, g of x, and h of x. Don't forget, and this is huge for today, that f of x is really just like the output of our equation, and anytime you see that, you can replace it with y. So if you don't want to type something extra on Desmos, you could just do y equals the equation instead of f of x. Alright, and we're going to go ahead and graph all 3 of those. Now, I've already graphed all 3 on my side of things, and so I have them over here, and I've hidden the other 2. So my first graph, x minus 2 times x plus 2, looks like this guy. Okay? With that graph, we need to identify 4 things: the vertex, the zeros, the axis of symmetry, and the y-intercept. So let's see if we can remember what each of those are. The vertex, I bet, is going to be pretty easy. That's kind of that either bottom, or if the parabola is going the other way, the top of our parabola. So this vertex is at 0, negative 4. And let's see, I should probably do this in red so we can see it. 0, comma, negative 4, and that is right here. Nothing bad. We'll skip the axis of symmetry for now, and let's focus on the zeros. The zeros are a fancy way to say the x-intercepts. Right, and we've learned that in our previous units, but it's good to reiterate. When they say find the zeros, they mean find the spot or spots where your graph crosses the x-axis. Can we see where this graph crosses the x-axis? Well, yeah, negative 2, 0, and positive 2, 0. So we have 2 zeros, and that's pretty common for quadratics. These U-shaped graphs should cross in 2 spots, like so. And then we need the y-intercept. Our y-intercept is where this graph crosses the y-axis, so just tell me when to stop when I get to the y-axis. Oh, stop right here? You're totally right. The y-intercept is actually the same as the vertex in this case, and that's not always the same, but we're good from there. And then, last but not least, the axis of symmetry. As a reminder, that axis of symmetry is the line that passes straight through my graph, vertically through my graph, that would let you fold one side of the graph onto the other. Now, imagine that this parabola was over here, right? The parabola is the name of our U-shaped graph. If it was over here, the vertical line would pass straight through, it looks like negative 4. If it was right here, this would be negative 3 on the x-axis, negative 2, negative 1. In fact, I could even do this equation, and I could say x equals negative 4. Right, there's that vertical line. What would I need to change this to get it passed through the middle of my parabola? Well, it looks like not negative 1, that's pretty close, maybe 0. Oh, there we go. Yeah, x equals 0 is that vertical line that passes through. You might also notice that the x-coordinate of the vertex matches up to that axis of symmetry, and that's not a coincidence. That will happen every time. So my axis of symmetry is the line x equals 0, and I like to do that with a little dashed line. And we're pretty good. Now, our main focus for this unit when we graph parabolas is to include 5 nice points. And you'll notice that I only have 3 here. But one thing we are going to learn, and we've seen it before, is that there's going to be an a value in all 3 of these forms. And we used our a value in topic 7 to create 2 more points from the vertex. And so if we look at this, my a value isn't written, so it's got to be an invisible 1, or maybe 1 over 1. So if I start at the vertex, could I go up 1 to the right 1, up 1 to the left 1 to find 2 more nice points? Is 1, -3 and -1, -3 on my graph? 1, -3 looks like it's right about there. Yeah, and its symmetric point is also there. And that's a trick we're going to use off and on. So here's my parabola. It doesn't have to be perfect. We have our 5 points. We're looking pretty good. Awesome. All right, we have 2 more of these, so I would say probably pause the video for now. Quickly do it on your own. If you need any help, you can listen to me talk you through it, but I hope that you're okay at copying these graphs. So get those done, quickly skim through, and we'll get the main part of today rocking and rolling. Ready, set, go. All right, you're back. I'm going to go ahead and tackle these other 2. We'll go a little bit quicker this time. Our next one looks like it has a vertex at 2, 1, and here are my zeros. So let's go ahead and put those in first. We have a vertex at 2, 1, and I had 2 zeros, 3, 0, and 1, 0. Notice that this parabola is going in a downwards direction. That shouldn't surprise you because there's a -1 out front. And when we learned in topic 7, if you had negative a values, the parabola went down. So 2, 1, 1, 0, 3, 0. Where are my other 2 points going to come from? Oh yeah, the y-intercept, of course. My y-intercept is 0, -3. So we have this guy right here. And then we should probably use that axis of symmetry. Again, it's going to correspond to the vertex. And so I bet my axis of symmetry is x equals 2, but let's check that really quickly. If I turn this graph on, there we go, yeah, right through the middle, nothing bad. So x equals 2, and we can put that here. And now it makes it easy to count the symmetry. We're 2 points away from the center. So on the other side, we're 2 points away from the center. And we can graph our beautiful parabola. Last one. Is there any of that information we could get from this equation? Well, it's a little bit harder here, right? This vertex 2, 1 certainly isn't in the equation. 3 and 1 are both in the equation, which is kind of nice, though they show up as -3, -1. -3 is kind of in the equation, and 2 is certainly not there. I think for now, let's just keep using Desmos, and then we'll see if we can find any more tricks or shortcuts as we go down the road. So our last one I'll do in green. The vertex looks real strange here, but it's okay. Oh, it looks like it's a decimal. 0.75, comma, -6.25. 0.75, comma, -6.25. It's a little bit off the graph here. It's not too bad, though. 0.75, if we zoom in, here's 0.5. 0.75 is a little bit closer to 1, and -6.25 is just past the graph here. Not too bad. We do our best to make sure the graphs fit our coordinate planes fit the graphs, but we're not always perfect. Maybe next year. All right, the zeros are also not great. -1/2 and 2. Well, that's not too bad. -1/2 and 2. So -1/2, +2. That's pretty good. Okay, I think we need 2 more points. Can we get it from the y-intercept? Yeah, 0, -4. And then that axis of symmetry we know is going to go through the vertex. So x equals 0.75. Looks something like this. There we go. And so it looks like it's, I don't know, 0.75 away, so maybe something approximately on the other side. Doesn't have to be perfect. And we're going to go nice and skinny, but continuing to go outwards. I do see a lot of students tend to make their parabolas just go straight up. Our parabola goes forever wide. It may not look like it, but it really does get wider and wider and wider as it goes out. And I obviously over-exaggerated it there, but don't think the parabola goes straight up and down. All right, so why did we spend so much time doing this? I'm going to go ahead and close this just so it doesn't kill my old computer power. I just got a new Donors Choose funded, so hopefully a new computer's coming our way soon, but this one's 9 years old and isn't doing great, but it's getting me through it, and it's been a trusty pal for the last while. So why are we doing this again? Well, what we're going to do now that we have all of this information about our graphs is we're going to try to find that information again, but without Desmos, because we actually have methods to find pretty much every piece. There's one part that'll take a little bit of extra, and it directly relates to what we've learned so far this unit. Weird, right? We learned something and now we get to keep using it. Exciting. So let's start with the basics. Given each equation, algebraically find the y-intercept for each equation. Well, that seems redundant. Note that your answers should match your graphs from above. Then double check your answers using a calculator. All right, let's look at this first one. They're asking us to find the y-intercept. But when we go through and find a y-intercept, we've done that many, many, many times. All right, a y-intercept, and we can see this up above too, always has an x value of 0. So to do that, we are just going to substitute 0 into each of these equations. So officially, that would look like us finding f of 0, right? I replace the x with 0. That's because there's an x of 0 here. And this will become 0 minus 2 times 0 plus 2. Now, sometimes this f of 0 thing confuses students because they're like, oh, there's an f, it's multiplying by 0. Don't overthink it. F of 0 means we plugged 0 in for x into the equation that's called f. But if that confuses you, just treat it as y. It's the same thing. Now, in order to evaluate this, right, we already have y alone. Y is already isolated. We just need to figure out the value of this. That means we're back to everyone's old favorite PEMDAS, right, elementary and middle school time. PEMDAS says do what's in the parentheses first, so that's not too terrible of math. There's no exponents, so now we're on to multiplication, and that's what does connect those. We get negative 4 here, and so my y-intercept is 0, negative 4. Did I do it right? Well, there's two ways to check. The first is you can absolutely type all of this into your calculator. In fact, I would suggest you do that on tests to make sure you don't make any silly arithmetic mistakes. But second, we know it's right because we've seen this equation before. X minus 2 times x plus 2 is the exact same equation as up above, and we already know the y-intercept is 0, negative 4. So I got 0, negative 4. It matched. Clearly, I did things correctly. And in fact, we're going to do that multiple times today. When we move on for the zeros, notice it's the same equation. And when we do the vertex, it will again be the same equation. So why don't you guys go ahead and try g of x and h of x, match your answers up above, and then you can hear me talk you through it if you'd like. Ready, set, go. Alrighty, we're back. Nothing too bad here. So when we find g of 0, it's just going to be negative 0 minus 3 times 0 minus 1. Now this question comes up a lot about the negative out front. It is an invisible negative 1. People say, well, wait, do I distribute it to the first set of parentheses or the second or both? What happens here? And really the best answer is you shouldn't distribute. There's no reason to. If you think about PEMDAS, none of the letters in PEMDAS stands for distribute. This D stands for divide, right? And so if there's no distribute in PEMDAS, and that's what we use to find a value, don't distribute. However, if you really want to distribute because it's your favorite thing in the world, the right answer is you should only distribute to one set of parentheses, not to both. Okay. Now, I'm not going to distribute because it's not part of PEMDAS. Distributive property is a shortcut, and it doesn't always work. The second question I get is this is negative 1 times negative 3 times negative 1. Now should I distribute? My answer is the same. It is still not part of PEMDAS. Don't distribute. We have finished parentheses. There's no exponents. We're on the multiplication. We multiply from left to right. So negative 1 times negative 3 is positive 3. And to finish this off, positive 3 times negative 1 is negative 3. 0, negative 3, quickly checking. Yes, we got it right. Whew, that's good. I'm still allowed to teach. Last one, h of 0. And remember, you can just write y if h of 0 scares you. And we're just going to keep following PEMDAS. This one's a little bit weird because there's some extra numbers inside, but I think you'll be all right. This is 2, negative 2. Let's do all this at once. 2 times 0 is 0. 0 plus 1 is 1. Okay, h of 0 is 2 times negative 2. That's negative 4. Is there even a point to multiply by 1? I think it's just negative 4 here, right? And yes, we've done it again. All right. So how do we find y-intercepts? You replace or you substitute 0 in for x. Every time. I don't care if you're in Algebra 1, Algebra 2, Calculus, whatever you're doing, to find the y-intercept in an equation with x and y, you replace the x with 0. And so that should directly relate to what we're doing next. They're asking us to algebraically find the zeros. Please don't forget that zeros is a fancy way to say x-intercepts. And so if for the y-intercept we replaced x with 0, then for the x-intercepts we are going to be replacing y with 0. There are almost always two x-intercepts, not always, but almost always. And so let's see if we can find them. Now, when we replace y with 0, this might look weird because you're like, where's the y? But f of x is the same as y. So there it is. Let's replace our y with 0 and see how we solve. Now this is different than our y-intercept because for the y-intercept, the y was already by itself, right? We had y alone, so we just got to use PEMDAS. Here, x is not by itself on the right side of the equal sign. So somehow we need to get x by itself. How do we do that? Well, you might be tempted to say, oh, it's the opposite. We just go ahead and use SADMAP, right? Well, no, because what we've learned over the last couple of classes is when you have multiple x's on the same side of an equation, we don't use SADMAP. We can only use SADMAP with an equation with a single x. So what do? Well, wait, isn't this equation equal to 0? And whenever we have parentheses multiplying to equal 0, can't we apply that zero product property, which says take one factor, one set of parentheses, and set it equal to 0? Or take the other one and set it equal to 0? Yeah. In fact, what we've done the last 2 days directly relates because of these x-intercepts. And to solve, we've done this enough. Add your 2 to both sides, subtract your 2 from both sides, and we now have our 2 x-intercepts. Let's finish this off. Same idea here. Substitute with 0. Common question, we'll keep addressing it. There's this negative 1 out front. Does it come with either of these? Do I distribute? Nope. We just worry about the factor. If you distribute the negative 1 inside, you will still get the right answer. It's not the worst thing in the world. It just adds more work. No reason to do that. 3, 1. So x is 3 when y is 0, or when x of 1 causes y to be 0. We should probably check those, and that looks pretty good. All right, last one, 0. Again, same thing here. Don't worry about that coefficient of the 2 out front. It's not doing anything. It's just hanging out observing. Okay. We do have a slightly more complicated equation for SADMAP. Add 2 here. Great. For this one, though, we have a 2 that's multiplying, a 1 that's adding. We know we undo addition and subtraction first, and finish off with multiplication or division. 2, 0, or negative 1/2, comma 0. Did I do that right? 2 and negative 1/2. Yeah, look at that. Excellent. Okay, so we know how to find the y-intercepts. And thanks to our newfound knowledge of the zero product property from 9.1, 9.2, we know how to find the x-intercepts. What's left? Well, you said it. It's the vertex. So here we go. The vertex is usually given by h comma k, right? So when we had our equation ax minus h squared plus k, it was really easy. We're just like, cool, h and k. But our new equation, which was that a, and we're going to do more with this later on, x minus q times x minus p. Neither of those letters are h and k, and that's on purpose. This is not the vertex. Nope, nope. We don't know it. However, we know that due to the axis of symmetry, our vertex is always going to be where? When you look at, let's do a different color, apologies. When you look at the x-intercepts, think about the x-intercepts and the axis of symmetry. What are you noticing? Well, hopefully you're noticing that the axis of symmetry, right, this line that goes right down the middle here, is exactly in between the two x-intercepts. And that axis of symmetry runs right through the vertex. So what is that telling you about the vertex? It tells us that the vertex is also exactly in between the x-intercepts, and that's going to be key for today. So let's fill that in. The vertex will always be exactly in the middle, or in between, of the two x-intercepts. In particular, that will be the h value of the vertex. Now, if all we need to do to find the vertex is figure out the x-intercepts and then find what's in the middle, then we should be just fine, right? For example, if I was over here and I said, okay, we know what our x-intercepts are, what's the vertex? You would say, well, in between 2 and -2, I've got a graph that's pretty easy. Here's 2, or here's -2, here's 2. Right in the middle of that, oh, that's clearly 0. So we know our vertex is at 0. And then you're like, okay, well, what's in between 3 and 1? We're really trying to stump you now. You're like, well, 2's in between 3 and 1. But then you get to this weird fraction. You're like, what's in between 2 and -1/2? You might have to pause and think. Or example, if I went a little bit further and I said, what's in between 12 and 100? Well, now counting gets what we would say a little bit tedious. I don't want to count between 12 and 100. So we have to think back to middle school math. How do you find what's exactly in between two numbers? And the answer is you find the average, specifically the mean of those two numbers. To do that, you take the two numbers, you add them together, and because we're adding two numbers together, we divide by 2, the number of numbers we're adding together. So this gives me 112 divided by 2, which is 56. 56 is exactly between 12 and 100, right? And you can see if you add, oh, what would that be? If you add 44 to this, we get 56. And if you subtract 44 from this, you get 56. Easy. All right. So if you know the x-intercepts of your graph, how can you use them to find your h value of your vertex? Well, it's not too bad, right? You have two options. Option 1 is just count between the x-intercepts. In fact, I do that most of the time if I have a graph. I'm just like, okay, 1, 2, 3, 1, 2, 3, great, we found it. However, if they're obnoxious, then our other option is we add them together and divide by 2. So we would do -3 plus 6. In this case, I got these numbers here, and divide by 2. So 6 minus 3 is 3. 3 divided by 2 is 1.5, which is the h, right? So we add together and divide by 2. Easy enough. But that's only half the battle, isn't it? If we said, okay, well, in between 2 and -2 is 0, or 2, or whatever this was, it was -0.75, no, it's positive 0.75, I think, right here, we are still at a bit of a loss because our vertex has two parts, the h and the k. So now we only have half a point. But wait, isn't that what we did for these last two? We had half a point. We knew it was 0 comma something. We knew it was something comma 0. And when we knew the half of the point was the 0, what did I do with the 0 in the equation? Well, I replaced the x's, because 0 is an x. I replaced the x's with 0. Easy enough, right? And if this 0 had been a 7, then I'd be replacing the x's with a 7. Or if the 0 was a 2, I'd be replacing the x's with a 2. So to finish off the vertex then, now that we have the h value, how do we find the k? Well, we substitute the h value in for x, and I'm going to draw two arrows here. Then PEMDAS, just like the y-intercept, and I'm also going to say or calculator to find, and I'm going to say the output, which is the k value. All right. So really the process isn't too bad. We had a lot of writing here, but all you're doing is finding a number in the middle and then putting it into the equation, and that's it. So let's try this. Okay, here's our first one. f of x equals x minus 2 times x plus 2. The first thing we need is the x-intercepts because the vertex is in between those. And man, oh man, did some of my students struggle. They're like, well, wait, I have to do all this math to find the x-intercepts? No, we did this on the previous page. So I'm going to say, see page 1, right? The x-intercepts here were 2, 0, and negative 2, 0. Same thing for these guys, right? They were 3, 0, and 1, 0. And last but not least, they were 2, 0, and negative 1/2, 0. Okay? Well, to find the h value, counting is easier. However, if you didn't want to count, you didn't have a graph, then let's show the actual math. We would take these two values, 2, and we would add it to negative 2, and then divide by 2. 2 plus negative 2 is 0, and 0 divided by 2 is 0. There is my h value. In fact, let's do all three of them at the same time. Okay, my second one, I would take these two guys, and I'd do 3 plus 1. I like to put them in parentheses just to make sure that let's put an h over here, just to make sure that I don't miss any negatives. 3 plus 1 is 4, and 4 divided by 2 is 2. So I know that the h value of my vertex is 2. And that's just a fancy way to say 2 is between 3 and 1. Last but not least, we're going to take our 2 and our negative 0.5. This one's a little bit trickier. So we're going to do 2 plus, and I'll just do negative 0.5 here, over 2 is going to be my h value. So this is 1.5 divided by 2. And ask yourself, if you had $1.50 and you split it in half, what would you have? You'd have 0.75, or 3/4 if you'd like. I tend to use decimals with points just because people seem happier with decimals on a number line. It's one of the only times that I don't use a fraction too often. Well, but that's only half the battle, 0, 2, and it's 0.75. How do we find the k? Well, whenever you have an x, to turn it into a y, you go back to your equation. I'm going to draw a couple arrows here so you don't forget what we did here. And we're going to take that equation, which was f of x equals x minus 2 times x plus 2. And we are going to take this 0 and substitute it in for the x's. So this gives us f of x equals, I'm going to set this up just so you can quickly see the substitutions here. I meant to do this, and I didn't mean to put x. There we go. We are substituting in 0. So f of 0 is 0 minus 2 times 0 plus 2. Okay, so f of 0 is going to be, we've actually done this exact problem before. No reason to talk you through it too slowly. 0, negative 4. There's our vertex. And again, you can check on the first page. K value, same idea. We need our equation, especially I do, because I've been the last couple of times messing up copying equations, so I want to make sure I do this carefully here. Might as well do the last one at the same time. H of x equals 2 times x minus 2 times 2x plus 1. There we go. And we know our input. We know our x value here is 2, or 0.75. So I'm going to take the 2 and substitute it in for all of my x's. So we're going to find g of 2 is negative 2 minus 3 times 2 minus 1. Again, PEMDAS. Negative 2 minus 3 is negative 1. 2 minus 1 is 1. Negative 1 is positive 1. So this just becomes 1 times 1. And I forgot parentheses, and all my 1's are in equals, and all my 1's are starting to look like parentheses, which is why I really should be putting those caps on there, but that's fine. And so that tells us that g of 2, 1 times 1 is 1. Last but not least, some 0.75 stuff. You might just want to do this one in your calculator. That might be much easier. 0.75 minus 2 times 2 by 0.75 plus 1. Right, and just write yourself a nice brief note. You can do this in your calculator. Okay, and when you do it, what should you get? Well, you know what you're going to get because we did it on the front page, of course. Right, you're going to end up getting that negative 6.25. Hopefully you get that. If you didn't, double check your calculator. Make sure you didn't use minuses in place of negatives or vice versa on this one. So negative 6.25. 0.25. And there we go. Nothing to it. So, with this, we've now found everything we need to know about how to graph our parabola in intercept form. So, let's write a quick conclusion, including why it's called intercept form, and then get to 2 practice problems to finish off the day. So here we go. We say quadratics that are in the form of f of x equals a times x minus q times x minus p, and brief pause, q and p, I don't know. That's what our district uses, it's what our textbook uses. You can use any letters you want. We say that those are in intercept, and by the way, sometimes my students will call this factored, and that's totally fine. Make your own name for it. Form. Now normally the giveaway that an equation is quadratic is because the equation has an x squared, I'll zoom in on that, an x squared term. So is this equation quadratic? How do you know? Well, we just spent a long time in topic 8 discussing this form of an equation right here, this x minus q times x minus p. And if I wanted to go through and make a really quick box, because of course these factors are the outside of the box, x minus q and x minus p, when you start to multiply this box out, whoops, there we go, in the upper left, x times x is x squared. And remember, the inside of this box is the same as the outside. It's just another way to represent it. So this equation does have an x squared term, right? The x squared term is just hidden in the parentheses here. So it's one of those forms you need to recognize. There's an x times another x. That is quadratic. The equation will make a parabola. So here's our summary. To find the y-intercepts for any equation, including this one, make sure you replace each x with 0. That's supposed to say x and not 0. Awkward. Replace each x with 0 and use PEMDAS to find y. All right, there we go. To find the zeros, which is another name for the x-intercepts, replace the y with 0. And then you use that zero product property. You make each one of these equations equal to 0. And then use SADMAP to solve. To find the vertex, which is certainly the most complicated part, first you find the h-coordinate. The h-coordinate is exactly in the middle of the 2 x-intercepts. Don't forget to find a number exactly in between the 2 others. You can always count, or you can just find the average of those 2, which means add them together and divide by 2. Once you have the h, then to find the k, you just substitute the h value in for x in your original equation. Okay, so let's try a couple together, and then you can do a couple practice problems to finish this off. Our first problem, if my tablet wants to cooperate here, there we go, looks a little bit weird. And that's because I don't see 2 sets of parentheses, right? The second one looks a little nicer, except for that negative 0.5. But don't forget, x is attached with multiplication, so you can throw some parentheses in there. Nothing bad at all. Let's find those x-intercepts. Replace y with 0. By the way, we do ask you to show this setup on your quizzes and on your test. We want to see that you're replacing y with 0 before you start doing all the extra stuff. Honestly, once you're here, if you can jump right to the answer, that's fine by me. I'm going to show both steps, though. We're going to take the x and set it equal to 0, and then also x minus 6 and set equal to 0. Solving the first, solving the second, done. Now, you could totally write these as points as well, but they're also just x-intercepts, so I'm just going to go ahead and put them on my x-axis. The y-intercept, pretty easy. We just replace the x with 0. So I'm going to write y just for the sake of clarity, and we have 0 times 0 minus 6. Do what's in the parentheses. 0 times negative 6, well, 0 times anything is 0. That might seem a little bit weird. You're like, the y-intercept is 0? Well, here's the y-axis. A y-intercept of being 0 is right here. In fact, it's right on top of the x-intercept we already found. Sometimes they are in the same place. This graph is going to cross both the x and the y-axis at the same spot. Now for the vertex. All right, vertex-wise, this is the tricky part. We know that the vertex has to happen in between these 2 x-intercepts. So can you eyeball it? 1, 2, 3, 1, 2, 3. It looks like the middle is 3. I'm going to go ahead and put this axis of symmetry here so I remember where that is. And then I'm going to say my vertex is going to be 3 comma something. Now again, I found the 3 just by counting to the inside. You could have added those together and divided by 2, but that seemed a lot easier. To find the y value, we're going to take our equation and we're going to find f of 3. So I'm going to leave some blanks really quickly here. So I'm going to find f of 3 in our equation, like so. And now we just do the math. Okay, this becomes 3 times, let's say 3 minus 6 is negative 3. And so 3 times, right, they're attached by multiplication, is negative 9. This means then that my vertex is going to be 3 comma negative 9. If we look at my graph, I did well setting up this x and y axis, and there we go. Now, you might look at this and say, well, wait, that's only 3 points. Aren't we supposed to have 5? Yeah, we do prefer that you have 5. So go ahead, take a look at your equation up here, and think about that a value, right? When we talked about this, there was the a out front. Well, the a out front is that invisible 1, which means from the vertex, always from the vertex, you can go up 1 over 1 in each direction. Once we're here, there's our parabola going out forever, right? It doesn't go straight up, it goes up and out forever. And that's important because the last part is they're asking for that domain and range. Our domain is how wide our parabola gets. Technically, it's what x's we're allowed to substitute into our equation. We can substitute any x we want. Here I substituted 3. Earlier I substituted 0. There's no restriction. And again, the way you see that is that my graph goes infinitely wide in both directions. So we say the domain is all real numbers, or you can be classy and just use that cool double bar R. The range is different though. The range measures all the possible answers you can get out from the equation. And we see that visually as a graph, on the graph, as the height. So how tall does this graph get? With these arrows, it certainly goes up forever. That's not too bad. What's the lowest it gets? Well, it looks like the lowest, the floor of this graph, is negative 9. So the way we say that is that the y's are greater than or equal to negative 9. You could also use that cool interval notation and say we start at equal to negative 9 and we go all the way up infinitely far. Okay, maybe one more example. Our last example here looks like this, but it's very similar as to what we did before. Start with the x-intercepts. Set 0 equal to the equation. Again, we do want to see this first step. We always want to see the setup to your problem. We want to see what you're trying to solve. If you can go straight to your answers, right, I can see that my answers are going to be 2 or negative 4. That's fine. I don't care about the middle part. However, if you want to be really meticulous and show all your steps, you set one factor equal to 0, or the other factor equal to 0, add 2 to each side, right? And you can show every step if you would like. But bare minimum, set up and answer. So we have 2 and negative 4. Now let's say, oh, no, well, actually I'm skipping ahead. Let's find the y-intercept first. That seems like a thing. Don't forget that you are allowed to use your calculator on this too. If all these decimals seem a little bit scary for you, go for it. I like to save this decimal till the very end and kind of hope it's an even number. So negative 0.5, this will be negative 2 and positive 4. And when you multiply those, that makes negative 8. I'm seeing half of 8, which is 4, and a negative times a negative is a positive. I'm seeing positive 4 for my y-intercept. Positive 4, that's up here. Okay? Vertex time. This is what I was trying to get to before. Now, let's say you are looking at this and you're like, oh my gosh, I can't count to find what's in between the two. Well, let's show the other way to do that, right? You would take your two x-intercepts, which are 2 and negative 4, and you would add those together and divide by 2. This will be my h. Negative 2 over 2 is negative 1. Now, I would assume that you could probably count 3 in this direction and 3 in this direction and come up with negative 1, but just in case, everyone's different. Negative 1 comma something. Then we need my k value, and the k value comes from taking that negative 1 and substituting it in for x in the equation. So negative 0.5, and then we end up with 1 minus 2, and 1 plus 4. So we get negative 0.5 times negative 1 times positive 5. If we do this, a negative and a negative is a positive, so that takes care of that. 1 times 5 is 5, so I'm just doing half of 5. I'm getting 2.5. Okay? Negative 1 comma 2.5. Now, does that point make sense? Negative 1 comma 2.5? I don't think so. That doesn't really make a parabola to me. That makes a very weird parabola, which tells me we went wrong somewhere. Can you see where I went wrong? Yeah, this was a negative 1, and it was a super common mistake that my students made. They forgot to carry the negative down, so it does change our numbers ever so slightly, right? Also, this parabola has a negative out front, and that means it is going to be going downwards, but it's going to be somewhat higher than that y-intercept, I think. So this becomes negative 3 times 3. This here will give you negative 9. Where is that? Half of 9 is 4.5, and a negative times a negative is a positive. So I think that means I'm actually at negative 1 comma 4.5. There we go. All right, through symmetry, I think we can find another point here. We had the y-intercept, that's 1 away. Here's my other. And let's get our beautiful looking parabola, downward facing parabola, rocking and rolling. Last but not least, domain and range. Domain, not a shocker, all real numbers. Range, the highest my graph gets is this point up here, 4.5. So the y's are going to be less than 4.5, also equal. There's a closed circle. We could also say that our graph starts infinitely low down here, and we go from negative infinity all the way up to 4.5. All right. The last part of this video is really just more graphing, so I'm going to leave you guys to it. It's nothing too terrible. If you get stuck on anything, you can ask your teacher. Don't forget, too, that you have Desmos. It's a great resource to check your work, but I'm not going to just go over and do all of them over and over and over again. I have faith that you guys can try these. So try each one. If there's anything you get particularly stuck on, let me know, and I can always make a follow-up video on these guys. But again, try them on your own. Use Desmos. If you get stuck, ask your teacher, ask me, and I think hopefully you guys are feeling pretty successful on graphing equations in intercept form. Next class, we're going to come back and talk about some word problem applications with this. And then finally for 9.5, we're going to discuss standard form. 9.6, the final lesson in this series, is just going to put everything together and give you a nice cheat sheet, guide sheet for how to graph all 3 types of equations, HK, intercept, and standard. So thanks for sticking with us. Hopefully this was a nice and neat lesson for 9.3, and I'm excited to have you back for 9.4.